All right, 11.5 starts talking about margin of error, and we're going to make predictions using margin of error. So in this scenario, we have Seth. It says he selects a random sample of students from a local college. There's a key right there. It's random. Okay, so we're going to assume that he selected these perfectly random. He has students that are in college and how far the college is from their home in miles. I want to know, how can Seth's sample estimate the proportion of freshmen in the population? So with this, what we could do is first off figure out how many students he sampled. So he did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he did 20 students. We're going to throw that down below. And then we want to know the proportion of freshmen. So let's go ahead and count freshmen up. We got 1, 2, 3, 4 freshmen out of 20. Okay, so since we have 4 freshmen out of 20, we could simplify it to say 1/5 of the population, or roughly 20% of the population is freshmen. Now, I want to know how accurate is that likely to be, and the key comes down to how random was the sample. If he took a random sample, it is going to be accurate. So random is going to equal pretty darn accurate. The other thing you got to watch out for, and what could he do to improve this, would probably be to up the sample size. But again, the key is random. If he picked them totally random, we're going to say it's pretty darn accurate. Okay. Example 1, try it. Then I want you to look at the data and make some conclusions as well from there. Moving on. Example 2. So we have Tia is contributing to the project as well. She did a different group. We want to estimate the proportion of freshmen again. So she counted 20. She got 8, which would be 4/5, or 40%. So I know, how can Seth and Tia determine whose result is a better representation of the population? We could go through and represent the data in different ways. Probably the biggest thing that they should do is get a bigger sample size. Okay, both of them have a rather small sample size, so if I want to improve it, we could sample more students. And that's what they, in fact, decided to do. So they examined more people, more samples, and this time they compared 50 samples of college students. So with this, if you look at it, Seth ended up having 20%, which was about the median. So Seth equals roughly the mean and median, whereas Tia's data, the 40%, is way the heck out here. Okay, so Tia is an outlier. So what we could say here is that Seth is actually closer to what the proportion of their percentage would be. So this really brings into play how sample size does matter. You do want to make sure you get enough people surveyed for a given question, and also to make sure that it's completely random. All right, the big thing for today is margin of error. Margin of error, it's a formula given right here. So it gives us the maximum expected difference between the result and the population parameter. So our formula is 1 over the square root of n, where n is the sample size. So how many people did we ask? The more people you sample, the smaller the margin of error will be. So on these, really, these are ones you should be able to do on your own. You're just plugging in the calculator. So you have a random sample of 100 Washington students reveals 40% plan to take the SAT. Margin of error. So our margin of error, MOE, is 1 over the square root of n. So 1 over the square root of 100 gives me 1/10, which is 0.1, which is the same as 10%. So they want us to use the margin of error to predict the actual proportion. What you do is you take the percentage they give us. So they gave us 40%, and we are going to both add and subtract the margin of error off of that. Okay? So if I want the interval, we're going to do 40 minus 10 gives me the 30. 40 plus 10 gets me to 50. And we can say with pretty great certainty that 30 to 50% of the students at Washington High plan on taking the SAT. Now, what we could do to improve the margin of error or lower it, so get our question to be like better to the value that's actually going to be, is to sample more people. The more people you sample, the lower the margin of error is going to be, which means that our data or the conclusions we're making are going to be more accurate for the population.